so sorry now.
Very exciting! We are embarking on a new adventure, solving quadratic equations. Quadratic equation is an equation to the second degree, and there is evidence that people were actually solving such equations before 300 BC. Why the picture of the fountain? Well, believe it or not, those sprays of water represent a parabola, which is a graph of a quadratic equation. And we'll be graphing quadratic equations later in the year. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. And this will be very important to use later on when we get to using the quadratic formula. Why do we call them quadratics? You would think quad means four, but quadratum is the Latin word for square. And since the area of a square of side length s would be s squared, a polynomial equation having an exponent of 2 is known as quadratic, square-like, derived from quadratus, which is the past participle of quadrare, which means to make square. I probably butchered those pronunciations, but Mr. Cutney can give you a better idea. So this is a quadratic expression. It can only be factored. It cannot be solved. In order to solve it, we need to have it as an equation. This is an equation and it can be solved. So in order to embark on this exciting adventure, we are going to have yet another property. The property we're going to learn about today is called the zero product property. And what does that mean? Well, any number times 0 is, drum roll please, zero. Now how does that help me? Well, if I know that the product of two variables is 0, what would that tell me about x, y, or both? We know if the product of x, y is 0, one of those variables must be 0. Both of them could be 0, but at least one has to be 0. Therefore, if I have quantity x plus 3 times the quantity x minus 7, if that product equals 0, what would that tell me? Well, either x plus 3 has to be 0 or x minus 7 has to be 0. Both could be, but one must be. And we are going to use this property in order to solve quadratic equations that are factorable. So, if you can factor, you will be able to solve factorable quadratic equations. Just to review, there are 3 primary types of factoring. Don't forget about our friend GCF, and then we have difference of perfect squares and our trinomial expressions. So let's get started. To solve a quadratic equation, we would want to put it in standard form. In order to have it in standard form, basically that means I need it equal to 0. We factor the quadratic equation using one of our methods, and we set each factor equal to 0 and solve each mini equation. The directions will say solve for x. They may also say find the roots. Starting with x squared minus x equals 6. That is not in standard form. Step 1 is to set the equation equal to 0 or get it into standard form. Step 2, we're going to factor. Step 3 is going to be to set each factor equal to 0, because the only way the product of two phrases equals 0 is if one of them is 0. Step 4, I would solve each mini equation, giving me x equals 3 or x equals 2. But there is no 8 product property, etc. If I had something like this, I can't set each of these factors equal to 8. I don't know what these could be. To get something equal to 8, I could have the square root of 10 times the square root of 6.4. Having a product of 8 doesn't tell me anything. So how would I solve this? I would have to expand the product of the binomials, subtract 8 from both sides, and then factor. Bear that in mind. Here we have some practice. So why don't you pause here, start factoring away, and come back and check your answers with me. Questions 1 through 6, the answers are here. Remember that I cannot divide through this equation if I set x squared equal to negative 3x. We cannot divide through by x to solve this. In doing so, we are ignoring the possibility that x could be 0. And in fact, x could be 0 in this case. So you would only end up with this solution, and you would be ignoring the fact that x could be 0. So we don't want to divide through. In number 2, we could take the square root of both sides. Remember, you need that plus minus. That's what gives me the 2 solutions. You can see that that has to be so if I were to solve it using difference of perfect squares, which is technically my method. I would have standard form y squared minus 16 equals 0, and then I would factor, and then I would get 4 and negative 4. This is just really a shortcut for doing the difference of perfect squares. When you are solving these, be sure to keep the equals 0 at every step until you've actually solved it. Also, when you factor out a GCF like a 2, we keep that in our equation, but we don't need to worry about it as a solution because 2 could never be equal to 0. We will talk about questions 7 and 8 in class, and we will work more with quadratic equations in the coming week. Have a great day, everybody.